More properties that I want us to look at tonight, then we'll look at them more in class tomorrow. The first one is the zero property. The zero property tells us, we can just write this on the outside, anything to the zero power is always going to equal 1. And we can write that on the inside. So we know that any base to the zero power is 1. It'll always be 1. That never changes. So for example, 5 to the 0 power equals 1. So that would also mean 3x to the 0 power would be what? 3x to the 0 power would be 1 as well. Doesn't matter what it is. If it's a variable, it's 0. If it's a number, if it's a variable, it's 1. If it's a number to 0, it's 1. Anything to the 0 power is just always 1. The next one I want us to look at is power to a power. So we looked at when we multiply powers, we know we add. But now something a little different is if we have a power, like x to the 6, but it's in parentheses like this. When this happens, we end up multiplying those two. So 6 times 2 will make it 12. So when it's parentheses, exponents are right next to each other in parentheses, we multiply them. And we'll look at both of these, why these happen more tomorrow. But power to a power, we multiply the exponents and keep the base. So for example, if we have something like 3 squared in parentheses, all to the 5th power, we just want to multiply these two. So we end up getting 5 times 2 is 10, 3 to the 10th power. With that. So another example, what about x to the 5th to the 6th power? What do we get here? We end up getting x to the 30th. Just multiply 5 times 6 to give us 30. And the last one I want us to look at is kind of two rules combined. If you have product, two exponents of different bases in parentheses, like x to the 6th and y to the 4th, and then we have a power outside of the parentheses, well, we can't combine these because they're different bases. So what you have to do with your exponent is really just distribute it to both powers. So we end up getting 2 times 6 is 12, so x to the 12th, and then y to the 8th. 2 times 4. That's our example up front. Let's write the rule down on the inside. So on the inside, so we're going to go ahead and put multiply exponent on the outside by all the exponents on the inside. The exponents with different bases that are on the inside. So for example, we have something like x to the 4th and y to the 3rd, all in parentheses with squared on the outside. We just want to multiply this 2 to both exponents. So 2 times 4 gives us 8, so x to the 8th. 3 times 2 gives us 6, so y to the 6th is our final answer. So the same thing goes if we have numbers. So if we had 4 squared, and then x to the 4th, and y to the 5th, all of that to the 4th power, go ahead and try this. See what you would get. Just distributing that 4 to all of the exponents on the inside. So when we do that, we distribute this 4 to all 3 exponents. 2 times 4 is 8, so we get 4 to the 8th power. 4 times 4 is 16, x to the 16th. and y to the 20th. And then we can just go ahead and leave it like that. So this 4 just got multiplied to every single exponent, and the bases stayed the same. All right, so with this, you can go ahead and cut along the dotted lines. Then I want us to put this in our notebooks. So after you cut along the dotted lines in your notebooks, this will go on the next 2 pages, so 17, 18. I want us to put exponent properties. And you'll have to do this tomorrow, actually, because we didn't get your notebooks back. But when you get your notebooks back, you'll do this, and you'll put it in, you'll glue it in that page.